Okay. So let's say we have a sum of sine and cosine. Very simple. There is actually a way for us to convert this into a single term of sine. Okay, so how do you do that? So this is actually related to the compounded angle formula. The compounded angle formula looks like the following. So if I use x, let's say let me call the other angle theta. It looks like this, right?
Yeah.
But this is missing, right? And the trick is to factor out the sum of the squares of the numbers in front of the sine and cosine. So the sum of the squares, so square the number in front of the sine and cosine. And if you square root that, right? You get root 2, right? So let's factor that out, root 2. Then you get sine of x times by 1 over root 2, right? Here we get a cosine of x times by 1 over root 2 as well. Now, can you find an angle, cosine of some angle that gives you 1 over root 2?
No.
1 over root 2. That's going to be 45 degrees, or pi over 2. Pi over 4, sorry. Yes. So, I can write this as sine of x cosine of pi over 4, right? But what about this one? Sine of pi over 4 also gives you that one, right? So I can convert this whole thing into x plus pi over 4. 2 sine ratio into 1 sine ratio. Okay. So here's what happened. See this one? I factor out the 1 and 1, sum of the squares, right? So if I actually imagine I create a triangle with the length 1, 1 as legs of the right angle triangle. So look, here this becomes root 2, right?
Yeah.
And I need this value, what's left over, to be the cosine of this theta, right? So cosine of this theta gives you this, right?
Yeah.
And the sine of theta will give you this. That's perfect. Using the same angle, it gives you the correct ratios that I want.